good morning. This is the new topic multiple integrals and the ongoing content is evaluation of double integrals. Assignment 1. Just start with a simple definition of definite integral. Suppose this is your interval AB and let me put points x1, x2, x3 so on up to xn in this interval. And suppose that taking this distance to be as delta x1, this distance to be as delta x2, and if you move further on, let this distance, the last one, will be delta xn, right? Okay, if I keep on increasing the number of points in the interval, then the number of subintervals also get increased such that the length of each subinterval tends to 0 and the number of subintervals or the number of points n tending to infinity. Then the definite integral from a to b fx dx is defined as the limits of the sum. Now x1, x2, x3 up to xn, these are the values of x, right? So we have to define as the limits of the sum, writing the function at x1, the value of the function at x1 into the length of subinterval, that is delta x1 containing the points x1. Then adding the value of the function at point x2 into delta x2, which is the length of the subinterval containing the point x2. So on, at the last we have f of xn into delta xn, the length of the subinterval containing the point xn, such that the length of each subinterval tends to 0 and n tends to infinity. Suppose I am having this integrand y equal to fx for fx greater than equal to 0, then this integral, definite integral from a to b fx dx, is numerically equal to the area bounded by the curves. Suppose the curves are x1 is equal to a and x2 is equal to b, and then y is equal to fx, and then the x-axis. So let's draw these curves. First is x1 is equal to a. This is your point A. So x1 equal to a is a straight line. And taking x2 is equal to b, another straight line. And suppose y equal to fx be the curve like this. And then this your x-axis. Now this definite integral is equal to the area bounded by these curves, which means this area. And because it is above the x-axis, the area is positive. What happens if the region falls below the x-axis? Suppose, again I am having x equal to, suppose x1 is equal to a be the first straight line, and x2 is equal to b be the another straight line, and suppose your fx comes out to be like this, right? This is your curve. Then I'm having three regions now. First one, the second one, and then this the third one. So the definite integral fx dx is equal to the area bounded by sum of these three areas, right? Now the area above the x-axis will take the point, will take the sign as positive, and the area below the x-axis will always take the point negative, and then this for third region I'm having the area having the sign as positive. This negative sign denotes that the area is below the x-axis. Please note that area can never be negative. It is always positive. But when this area will enter into the algebraic sum, then it will take negative sign with it when it enters the algebraic sum. And the area above the x-axis will enter the algebraic sum with positive sign, right? So this negative sign denotes that the area lies below the x-axis. Fine? Okay, now is the double integral. Double integral is its counterpart in 2 dimensions. Let fxy be, now here I'm having function f with 2 independent variables x and y. And let this function be a single valued and bounded. Please look at the figure over here. Let fxy be defined in this closed region R in the xy plane, and let me divide this region into the number of rectangles by making the lines parallel to the x-axis and making the lines parallel to the y-axis. Suppose I have divided this region into n rectangles, from 1 to n rectangles. Let's consider this rectangle to be as rth rectangle, and this rectangle containing the point xr, yr. Suppose you can take any rth rectangle, right? Now, if I keep on dividing this region, or if I keep on increasing the number of rectangles by making more and more lines parallel to the y and x-axis like this in the figure 2, such that this rth rectangles, the area of the rth rectangle will tends to 0. Then this double integral over the region R fx dy, the value is equal dA. This dA is your area. So this is dx dy. So the value of this double integral is equal to summation R going from 1 to n f of xr yr, right? And into, in the previous for the definite integral we have taken the length of the subinterval, that is delta x, but here we will take the area, delta area. So this is delta AR. This is representing the rth rectangle, the coordinate for the rth rectangle, and the value of f at that point into the area of the rth rectangle, right? And limit should be, now these are the sum, and the limit should be having n tending to infinity and delta AR tending to 0, right? Now the evaluation of the double integral. Now here I'm going to define 3 methods, right? And if you understand these 3 methods, it will be very easier for you to calculate any kind of the double integral. So first method is, let region R be the region bounded by the curves x equal to x1, x equal to x2, y equal to y1, y equal to y2. First, if x1 and x2 are the functions of y and y1, y2 are constants. Now in the first method, if y1 and y2 are constants, which means, suppose this is your y1 and this is your y2. These are the constants, right? So this is y equal to y1 and this is y equal to y2, right? And then x1, x2 are the functions of y, which means, suppose this is your x1 and this is a function of y, which means the value of x1 is in terms of y. And this is another curve x2 having value in terms of y. It is also a function of y. Now please note here, whenever you are having y1, y2 as your constants, then you will make your strip parallel to x coordinate axis, right? Like this. The strip will be always parallel to the x coordinate axis, having this small distance as delta y, right? This is your y coordinate axis, this is your x. So please remember, when y1 and y2 are constants, make the strip parallel to the x coordinate axis, right? And the formula becomes double integral over r fxy dx dy is equal to, now because y1 and y2 are constants, keep the limit outside, and inside keep the limits x1, x2, which are the functions of y, right? And you have to integrate first with respect to dx, because when you integrate this with respect to dx, finally you are going to have your expression in y, because x1 and x2 are the functions of y. It can be any, like suppose this can be 1 plus y square under the root, anything, any value in terms of y, right? So when y1, y2 are the constant, please keep their limit outside, and inside keep the limits as x1, x2, which are the functions of y. And because y1 and y2 are the constants, you have to write dy at the last. Fine, this you have to make a very clear. Next, when y1, y2 are the functions of x and x1, x2 are the constants. Now here x1, x2 are the constants, which means this is your straight line and this is your straight line. This is x equal to x2 and this is x equal to x1. Now x1, x2 are the constants. So write x1, x2 limits outside of the integral, right? And because x1, x2 are constants, you have to write dx outer side, right? And inside, writing the limits y1, y2, which are the functions of x. So let this is your curve. y1 is equal to phi 1x and this is y2 is equal to phi 2x. These are the functions of x, and because y1, y2 are the functions of x, you have to integrate with respect to dy. Okay, now the strip should be parallel to, what are the constants? x1, x2. Strip should be parallel to y-axis. Very good. Like this. जो कांस्टेंट्स होंगे उनके पैरेलल स्ट्रिप नहीं बनानी, जो फंक्शंस ऑफ y और x होंगे उनके पैरेलल बनानी होती है, ठीक है? सो दिस इज द डिस्टेंस डेल्टा x. यहाँ पर x1, x2 कांस्टेंट है, तो हम स्ट्रिप y कोऑर्डिनेट एक्सिस के पैरेलल बनाएंगे, y एक्सिस के पैरेलल बनाएंगे. तो इस केस में x1, x2 कॉन्स्टेंट्स है, dx बार लिखना है और अंदर इंटीग्रेट करना है विद रिस्पेक्ट टू y, क्योंकि y1, y2 आपके x के फंक्शंस हैं. आपका सारा का सारा एक्सप्रेशन x में आने वाला है, ठीक है? और फाइनली बाद में आप फिर विद रिस्पेक्ट टू x ही इंटीग्रेट करोगे, ठीक है? थर्ड, जब आपके सारे ही कॉन्स्टेंट्स हो, x1, x2, y1, y2 सभी के सभी कॉन्स्टेंट हो, तब हमारी चॉइस है, हम वेदर आप सबसे पहले y विद रिस्पेक्ट टू y इंटीग्रेट करो, बाद में विद रिस्पेक्ट टू x, या फिर पहले विद रिस्पेक्ट टू x और बाद में विद रिस्पेक्ट टू y. इट्स योर चॉइस, इट्स अप टू यू, राइट? ओके, So let's start. Let's do one example which will make you more clearer. So the example 1 is double integral having the limits 0 to 1 dx dy over square root of 1 minus x square into 1 minus y square. अब यहाँ पर देखो x1 x2 y1 y2 सभी के सभी कांस्टेंट्स हैं, है ना. यहाँ पर लिमिट्स देखो सारी की सारी कांस्टेंट्स हैं. तो अब हमने क्या करना है, जैसे मर्जी आप ले लो, विद रिस्पेक्ट टू पहले x करना है या विद रिस्पेक्ट टू y करना है. सो आई एम गोइंग टू integrate first with respect to x. Into square root of 1 minus y square. Because I am going to integrate with respect to x, ये तो वैसे ही इसके लिए constant है, इसको बाहर लिख लेते हैं. 0 to 1, 1 over square root of 1 minus y square. 0 to 1 dx over 1 minus x square root dy. ठीक है, इसकी इंटीग्रेशन 0 to 1 over square root of 1 minus y square. Now integration of 1 over square root of 1 minus x square is sine inverse x. Putting the limits, you will get, what is sine inverse 1? It is pi by 2 minus sine inverse 0 is 0. Keeping this pi by 2 now outside and integrating the rest of the function with respect to y. So this is equal to pi by 2. Again, this integration is sine inverse y 0 to 1. And this is pi by 2 into, okay, sine inverse 1 is pi by 2 minus 0. And the final answer is pi square by 4. Fine? Okay. Let's move on to the second example, where two limits are constants and another one is three limits are constant and the last one is having the function of x. Now this limit is in terms of x, which means this is y2. Yes, this is your y2 and this is your y1. Because we know that y1, y2 are always in terms of x if it is given to be, or x1 and x2 in terms of y, right? So this is y1, this is y2, then you will write this as your x1 and this as your x2. Is it clear? Should I move on to the methods to make you more clearer? Please look at here. y1, y2 are always the functions of x, right? If you are given the function of x in terms of x, then that is your y2, right? So here the function is given in terms of x, so this is your y2 because it is your upper limit, so this is your y2, and this is the lower limit, taking this as y1. Now is it clear? Okay. Now how to integrate? Because x1 and x2 are constants, I must write dx outside. Yes, जो constant होंगे वही वाला वेरिएबल dx वाला बाहर लिखना, 1 plus x square, and integrating this with respect to y. This is 1 plus x square plus y square. Is it fine? Okay. So this is equal to 0 to 1, 0, 1 plus x square, square root. Can I write this as, because I know one formula, can I write this as 1 plus x square under the root whole square plus y square dx. Now this integration is, we all know that this is taking this as your, because this is constant for this integral, inner integral, because I am integrating with respect to y. So taking this as your a. So this is a square plus y square, where a is square root of 1 plus x square. So the formula is 1 over a tan inverse y over a. Right? Dx. Putting the limits from 0 to 1 plus x square under the root. So this is 0 to 1. This is your constant for inner integral. Now putting here value of y as square root of 1 plus x square, that will give you tan inverse 1. So tan inverse 1 is pi by 4. And then putting the value of y as 0, so tan inverse 0 is 0. So this is your dx. And then taking this pi by 4 outside, dx over square root of 1 plus x square. Now integration of 1 over square root of 1 plus x square is, yes, this is log of x plus square root of 1 plus x square. Very fine. From 0 to 1. Putting the limits now. Putting 1 as, so this is log of 1 plus square root of 1 plus 1, that is square root 2. So this is 1 plus square root of 2 minus. Putting 0, you get log of, this is 0, this is 0, this is log of 1. So this is equal to pi by 4 log of 1 plus root 2 minus log of 1 is 0. So your final answer is pi by 4 log of 1 plus square root 2. This is how we solve the double integrals. We will continue some more examples in the next assignment. Thank you so much. God bless.